This is a very special night, and it's so special that I'm going to do something I infrequently do, which is recede into the background. No, seriously, it's not because like I'm exhausted from spending an afternoon. Yeah. Well, there is that, Dr. Leshin.
Laurie, please.
Oh, Laurie, there is that. No, I'm not exhausted from an afternoon of teaching undergraduates. And I'm not exhausted because I haven't managed to shake the dust from my solar arrays. No, I'm just awed by the amazing panel of women here tonight. My podcast, as you know, deals with the past, with the origins of JPL. But tonight, we're going to be able to look at the present and the future. But before we launch into the future, I'm curious about how all of you got here and how you racked up those biographies. Dr. Leshin, Laurie.
You want me to go first?
Yeah.
You want me to go first? Well, first of all, hi, everyone. Thank you so much for coming out. Isn't it wonderful to be in a room with humans? Like, it's so great. I'm so happy to be here and have been a huge KPCC fan since I lived here the first time, which started back in 1987. So I'm really thrilled to be back in California. Let's see. For me, I guess I would just talk about two quick things. So I grew up in Arizona. Outside Phoenix, and I remember very distinctly standing in my mother's kitchen as a 10-year-old girl, seeing the first pictures from the surface of Mars from the Viking landers. And I remember just being transfixed by these images, and there was just something about them, probably because I grew up in the desert and it sort of looked familiar. But I just fell in love with that landscape, and I just wanted to reach out and touch those rocks. And I won't sit up here and say I was one of those people that, like, from that moment on, I knew that was the only thing I cared about. That's not true. I had other interests too, but it just animated so much of my interest: is love of the outdoors, love of rocks, and love of Mars, and all things space. So that kind of probably set me on my path, and then I came to Caltech for my PhD, and during that time, I got to study Mars rocks, which was really exciting. Martian meteorites that we think were blasted off the surface of Mars and landed on the Earth. Studied them, understanding water on Mars. And right after I graduated, I was working at UCLA, and I got a call from a reporter at the LA Times saying, some NASA scientists think they might have found fossils in one of these meteorites, one of these rocks that you studied. What do you think about that? And I remember at the time sort of saying, well, I haven't read the paper, I don't really know, hanging up the phone, and thinking back on the scientific conferences where there were like the 24 of us in the world that ever studied these meteorites, fighting it out. It was great. But I thought, well, man, maybe there'll be a few more people there at the next conference. Literally the next day, when it was announced publicly, it was the headline on every newspaper in the entire world: Life on Mars. President Clinton gave a speech about our meteorites. Like, it was literally 24 of us in the world that used to study them before that. And at the next conference, there were 1,000 people in the room, including a lot of reporters. And for me, it was such a moment of clarity about the work that we get to do as scientists, as people exploring space, how much it can really spark people's imaginations. And I think that was really the experience that started leading me out of the lab and into leadership to help enable that to happen more frequently. And then the last thing I'll say is I've been really fortunate in my career. I had a very good academic career. Then I ditched my tenure and went and joined the government for a while, worked for NASA. And I've been able to sort of hop back and forth. And that breadth of experience, I think, has served me very well. And I just will say I am so thrilled to be the director of JPL, and I'm having a ball. So.
But Laurie, is it really true that you knit in your spare time?
I knit very slowly and very poorly. I do. I taught myself to knit on YouTube, and because why not? You can teach yourself almost anything. And so yes, I'm a knitter and a weaver. I actually have a sort of very simple loom as well. I don't know. There's something very zen about it for me when I just need to kind of clear my head doing fiber arts is wonderful.
Right. Well, so Nagin, I think all of you followed different paths, but I interviewed Nagin for my first book about JPL that came out in the. Yeah, when we were youthful, when I didn't have dust on my solar arrays. But maybe you could talk a little bit about your path, which includes ROTC, and maybe.
Does, yeah. Well, first of all, thank you for everybody for being here. I know there was like SIG alert on the 210, and so we're very glad to be here. And yay for Laurie, first female director, sharing the stage. Woo! Yeah. So as MJ was saying, my path was a little bit different in that I was born in India and grew up in the United States, but in a household where very early on it became clear to me, I couldn't figure out what was going on. And I mean, I was very young and eventually realized that there seemed to be a difference between the expectations of the boys in the family and the girls in the family. And so early on, I got exposed to how we find ways to divide ourselves. And at the same time, as I was experiencing that firsthand, I also was fortunate enough to be seeing some of the early space shuttle missions and the late Apollo missions and seeing how those brought people together. And so, how melodramatic teenagers are, I decided I wanted to do something for all humankind. And so for me, then, that's how I became aware of the space program. And at the time, Star Trek, Star Wars, that was going on. I mean, the media has such a power to inspire. And so I had some friends who were interested in Star Trek, and I suddenly saw this vision of a hopeful future. And the bridge of the Enterprise had women and Russians and people from everywhere. And it was inclusive at the time. And sometimes now I think, what if that show hadn't had such an inclusive cast? And so for me, then, my friends kind of moved on in a couple of months. They were moved on to like Nancy Drew mysteries, I think was what they got interested in. But then I rapidly realized that it didn't have to be science fiction. There was actually real science happening. And at the same time, the original Cosmos was on with Carl Sagan, and that was my first exposure to robotic exploration. And so never wanted to be an astronaut, because if you want to go first, it's the robots. And so at the end of...
I've heard other engineers say the two words for not becoming an astronaut are Magic Mountain.
Well, there's the physical aspect, but there's also
the physical aspect.
That the robots, if you really want to go where no one has gone before, that would be the robots. And at the end of Cosmos on Sunday night, it would say, Carl Sagan, Cornell University. So again, the thought process of teenagers, I was like, aha, I shall go to Cornell University. And that is, in fact, where I was fortunate enough to go on an ROTC scholarship, an Air Force scholarship.
Well, my memory from our first interview is that maybe your father wasn't all that eager for you to be an engineer. And ROTC might have been a strategy to thwart him.
That is very true. The finances in the family were targeted for the boys to be able to go to college, and so I needed some other resources. And back then, you had to actually go to the library and look at a book to see what colleges were like, and there weren't a lot of pictures, and I noticed that, and there wasn't a lot of information to be had on a place like JPL, but I did notice that the astronauts had military background. So then when my high school had a recruiting trailer that said Air Force, I knew, and I remember, it's amazing the moments that your life turns on, right? I took a shortcut through the back of my high school, and I saw that trailer, and I could have kept going, but I remember I looked up and went, oh yeah, there's something about the military, like the astronauts. And so I walked up the stairs, and that was how my path started and I owe the Air Force everything, duty, honor, country. They paid for my undergraduate, paid for my graduate school. I loved being in the Air Force, but there was this prior goal to get to JPL. And so I left the Air Force and was fortunate enough, as you said, before there was dust on our solar arrays many moons ago, that I joined JPL, and it's now been, I guess, having worked 5 or 6 missions for 4 or 5 years each, suddenly it's been 25 years. And it's as much fun as the first day.
I love this lounge singer, Mike, so much. Morgan, you grew up on the Space Coast.
I
When did you
did.
decide that you wanted to, was it always a constant presence?
Yeah, growing up right next to where the space shuttles and all these rockets were going off, I mean, how could you not be inspired and influenced by that? And my dad actually worked for NASA, for Kennedy Space Center. So it was always an element. I don't think I really realized that that could be a career option for me until I went to college and started studying chemistry. And one of the things I love about NASA and planetary science is there's so many different fields that are super important. So you can study chemistry or physics or biology or even, oceanography now is becoming a really important field for us. So I started studying chemistry, but just like Nagin was talking about one pivotal moment changing your life, I remember I was a junior in undergrad. I stayed in-state. I went to a school in Florida, and I was going to apply for internships. But exams had happened. I was busy cramming, and so by the time I went around to apply, there was only one left, and it was at JPL. It was for an undergraduate research program funded by NASA. So I applied and got very lucky and got in and came out, stayed in the dorms at Caltech, got bused to JPL, and fell in love with both places and the work I was doing. And so I really haven't ever left since then. I stayed as a graduate student at Caltech. I got my PhD in chemistry and have been exploring all these interesting questions like, are we alone in the universe since that time, and just having a blast doing it.
My understanding is you're also working on Europa Clipper. All these you mentioned oceanography, all these water-covered worlds like Enceladus and Europa. I hear you surf. Is that like a busman's holiday?
Possibly, at least here on Earth, that water is on the surface, so it does make it a little bit easier, although I would love to surf the liquid hydrocarbon lakes of Titan. That would be amazing. Don't bring a match, just kidding, there's no oxygen, it's fine. But I do really enjoy thinking about those kinds of things when I'm surfing. It's one of the ways that I relax. I'm sure we all have different hobbies that help us kind of get away and enjoy and recharge.
Well, I'm actually curious what a JPL director does. I interviewed directors in the past. What is your day like, Laurie? What is a typical day in the life of a JPL director?
So their answer is there is no typical day. Every day is different, which makes it really exciting and interesting. Shall I briefly walk you through yesterday? Yesterday was a pretty interesting day.
Do it.
So yesterday, I started at 8 a.m. with a meeting with my governance committee of the Caltech board. So JPL, as was mentioned in the intros, is operated by Caltech for NASA. And so we are governed by Caltech. And so I have a committee of the board that I work with. So I met with them and gave them updates on what was happening, and that all went great. That was the most boring part of the day, even though the people on that committee are amazing. I have got former CEO of Northrop Grumman and the former CEO of Orbital ATK and the former Secretary of the Air Force. Like, there are incredible people on that board who are helping us. But anyway, then I raced to JPL because the mission manager of the Artemis mission, everybody remembers Artemis, the big giant rocket that just sent Orion around the moon and back, very exciting milestone for NASA. You would think, but Laurie, you don't do that stuff at JPL. We don't do the human spaceflight stuff typically. But guess what? Any mission that goes beyond Earth, we track with our Deep Space Network. And so the mission manager for Artemis came to JPL to thank our team working on the Deep Space Network, brought for them a certificate which flew inside Orion around the moon. We were the very first place that he came after these certificates were extracted from inside Orion, and thanked our Deep Space Network team, which was fantastic. It was so great for them because they worked their butts off to support that mission, and it was incredible. So I did that. Then I raced immediately to an all-hands meeting for our Mars sample return mission, which is our next big Mars mission. And we're rallying the troops. We're at a critical moment where we're really maturing our designs and in a kind of a crunch phase of that mission, so kind of rallying everybody around that. And then after a couple of other meetings, we went to prepare to receive the data for the last sample tube drop from Perseverance rover, which is driving around Mars and actually collecting the samples that Mars Sample Return is going to go get. And it's creating a little cache on the surface by dropping some of the tubes. So we were waiting for the final downlink of data from that cache thing. It turns out there was a little glitch, but we'll get it in a couple of days. It's all good. Everything's fine. Almost. But you know what? That's how it works. Doesn't always work, right? That's okay. That was thrilling. And then went to another meeting about an anomaly we're having on one of our missions, another little glitch, which we'll work through. Oh, come stop in, Laurie. We're doing the pre-ship review for our radar mission that we're doing with the Indian Space Research Organization, ISRO. We're about to ship that mission to India for the final integration and launch. This is going to be an incredible Earth science mission looking at the solid Earth. And then lastly, I stuck my head in one of those preliminary reviews on Mars Sample Return, the lander mechanical system, where I got to see a life-size printout of how big this lander is, and it is as big as this stage and taller than me. By far the biggest thing we will ever send to Mars. That was literally yesterday. That was my day.
That's, yeah, I think we deserve a
Crazy.
little.
Crazy.
And you went through the whole day in those heels.
No.
No.
No, these are just for y'all. I wear flats at work most days.
I had to ask you to share. It just made it, too amazing.
Yeah, it's never boring, I will tell you. It's just a thrill, all the different things we're working on.
Well, actually, speaking of never boring, I also hear that Morgan has another really interesting hobby, mountain unicycling.
Yes.
I'm curious about how many other people do that hobby. And
Anyone?
There are a few.
Yeah.
There's at least
Okay.
one person in the audience. My husband who taught me how. So that summer internship I was telling you about, I met this really cute guy at Caltech, and he taught me how to unicycle, and now we're married. But I love this sport. And this even includes surfing. This is the only sport, mountain unicycling, that I have to be completely 100% focused on what I'm doing. I can't let my mind drift to the meetings coming up, the next analysis we're going to do with the Perseverance
Mountain
rover.
unicycling on Titan.
Yeah, that would be
imagining
amazing.
that. No.
Well, the gravity's less, so you could do so much more. You could get more air. That'd be amazing.
I found it even challenging to climb onto the stage tonight.
Exactly.
I think I would have felt more confident if I was on my unicycle. I'd say. But no, I love it. I feel like it's like meditation in motion is a good way to describe that, and I think it's important for us all to have an outlet where we can do that. So.
You have amazing balance.
And I wear lots of pads and a helmet. Very important.
That's a consolation. Well, actually, back to hobbies. For a lot of billionaires these days, space travel, or at least suborbital flight, seems to be a very popular hobby. If SpaceX gave you a seat on the Dragon, would you go?
Heck yeah.
Yep, absolutely.
All right, that was an
Farther
easy
the
one. Well, then besides tourism, since I started doing this reporting back in, the middle 1990s, the idea of private space was kind of a joke, the private space enthusiasts would say space is a program, space is a place, not a program, and everybody would laugh, but they're not laughing anymore. And I imagine that some of the, I don't know if any JPL satellites have been launched on SpaceX
Yeah,
rockets,
we did one
but-
in mid-December.
Yeah, maybe talk a little bit about the role of private space with
Sure.
NASA.
I mean,
I also, weren't you involved a
Yeah.
little bit with that at
Yes,
NASA
I was.
headquarters?
Yes, I was.
Good.
So my last job at NASA before running back to academia for a few years was in the Future Human Spaceflight program, what's called the Exploration Program. It's actually the program that launched Artemis, that launched the Space Launch System, and we sort of invented that rocket back when I was there 10, 12 years ago. But the other thing we were working on at the time was the Commercial Crew Program, where we were starting to be sort of initial investors in some of the companies, including SpaceX, also including Boeing, but SpaceX was more in the startup mode to try and have the astronauts be able to access the International Space Station through private means, buying seats instead of rockets, right? Buying a service instead of a vehicle. And so like Uber for astronauts, I guess, but you can't call it on your phone, yeah. So we were right at the very beginning of that, and lots of people thought it was crazy, and it was a big culture shift for NASA, and it's just so thrilling to see it successful. First of all, after 10 years of not being able to launch U.S. astronauts from U.S. soil, it's thrilling that we can once again do that, and Elon gets a ton of credit for that from me. And they've done amazing stuff. And then, of course, the SpaceX rockets, we just launched a surface water observatory out of Vandenberg in mid-December on a Falcon 9. It was his 6th flight. I was about this far away from it on the launch pad, not when it launched, like 12 hours before it launched. It was all blackened and sooty because it's flown a bunch of times, and then it flies right back right afterwards. 8 minutes after launch, the first stage is back on the 100 yards from the pad. It's really an incredible
Exactly,
thing.
the reusable aspect is just
Incredible.
mind-boggling.
Incredible.
You're about to say something.
Yeah.
Well, and one of the things that I get asked a lot is how competitive is it between JPL and SpaceX, right? And we're obviously all in the same relative neck of the woods in LA, and so we find that we trade engineers, right? They'll be at SpaceX for a while and then come to JPL and vice versa, and clearly it's different. We're not in the launch business,
the
but
rocket business,
from our perspective, we need a ride, so it's groovy that they're working on
100%.
bringing the launch costs down, and competition is good, right? It helps everybody innovate, and they're able to take some of some risks that that when something doesn't go right for us, we kind of see it on the front of the newspapers, right? Whereas when SpaceX has the ability to just kind of keep going, if they have a failure, in that spirit of perseverance is both at JPL and at SpaceX, but it's good to have different organizations trying to do similar things so that everybody benefits from the new ideas.
Morgan is about to leap in.
That spirit of perseverance, I see what you did there.
Yeah, that was good.
Did you hear that?
I like to think of it as, NASA does the firsts. We dare mighty things. We do the things first, and then after that, the commercial space sector can come in and make it cheaper, faster, better, more accessible. And so I think that it works really well, and
It helps NASA stay focused on the frontier, right?
Exactly.
And so it's a really important part of the ecosystem, and to see it expanding so quickly the way it is, and so much innovation, and we can learn from them, and they have obviously learned from us. It's thrilling, and I don't think anybody, if you said, well, what's it going to be like 15, 20 years from now, I wouldn't believe any prediction you read. It's going to be too exciting to be able to understand today.
Will Elon get to Mars before NASA?
Well, we're on Mars now, so no.
Well,
We're already there, and we have been.
Sorry, that was rude. So we've been on Mars continuously for a quarter century, for 25 years, since we landed
Since that
adorable,
fat,
back to Pathfinder. But humans, you mean?
yeah.
Oh, then.
I'd be surprised, but then again.
Well, but I was just thinking of the I'm
Starship.
searching for a euphemism. No, the spinning of disastrous consequences with galactic cosmic ray, whatever, high energy,
Sure.
heavy ions from outside our solar system. I think
It's tough.
astronauts are going to.
It's a tough get.
I often wonder about the wisdom of sending people. That's going to alienate everybody in the room.
Well, and
I
it's-
often wonder about the.
Alienate. No.
And it's
In a
it's
spirit of
partnership.
perseverance, I'm just going to
And
keep
curiosity.
taking it.
But if you see if you're at SpaceX and you see some of the pictures that they have on the wall, the artist's rendition, right, of humans on Mars and a base and kind of the beginnings of a colony, one of the things that's always interesting to look at is if you look behind the humans in the picture, you'll see all the little rovers running around. One of them even says Moxie, and Moxie is what we're flying on Perseverance. It's the oxygen, the prototype of an oxygen maker that we're flying now. So if you are, whoever sends humans to Mars, there's a lot of robotic work that's being done to prepare the way, right? The weather stations that have been on all the rovers, Curiosity, the Curiosity rover has a radiation counter on board because we need that information to make spacesuits. So we have science objectives on these robotic missions, but we also have objectives to enable human exploration in the future.
But I think that's, a little bit of a race. I'm less worried about that race than I am about the race with China.
Oh, that's really interesting in the light of the founding of the Jet Propulsion Laboratory and the fact that we deported Chen Shushen, who was one of the early rocketry pioneers at JPL. You're looking at maybe the first 7 episodes of my podcast. No, you're not looking, you're listening. But I mean, he was a Chinese national whose in-laws had actually fought, for the nationalist cause, and he was accused of being a spy, and we deported him in 1955.
Yeah, that was before my time. Yeah. But yes. Yeah.
No wonder your solar arrays are so
Exactly.
are so tidy.
Yeah.
We, in a way, we started the Chinese.
He was the
space
father of the
program.
Chinese space program. That's right. Yep. Interesting.
So so I guess China is our biggest competitor then, or how do you?
Yeah, I think so. I mean, things with Russia are. Russia is still our partner on the International Space Station, which is kind of amazing given global events. But that has worked, and people are collaborating. There's lives at stake up there, and so it's really important they do. But China, we are not working with, and we're prohibited by law from doing so. And they're moving incredibly fast, investing a lot of money and moving incredibly fast, and doing so through their military. So it's something very much to pay attention to. I think on the U.S.
it's a challenging situation.
It is. Yeah.
I think the one thing that we found is that when barriers do come down, at least from the perspective of a scientist, we tend to achieve better when our teams are more diverse and bring different perspectives. And so it's been really amazing to just see, even in my time at JPL, that getting better and better, and our teams looking more like, the demographics of our nation. And I think that's really amazing.
Well, actually,
Yes.
that's definitely
It's getting better.
that definitely is an applause sign. But I mean, the quality. No,
You're funny.
the quality. Since the middle '90s, when I first met Nagin, the quality of people I've been interviewing at JPL has just been so high, and yet. A lot of people in tech can make more money in industry. Is it a challenge getting the best people?
Yeah, it's interesting.
Does Elon purchase them? Or?
Yes, Elon and Bezos too.
Yeah.
Bezos.
Well, Blue Origin isn't doing so well.
Oh, they're hiring a lot of people. Yeah, and look, I mean, that it is more competitive now than it has been previously, and my colleagues here who have been at JPL longer than I have can attest to this. There's the wonderful proliferation of the space ecosystem. It's great for the future of space exploration. It means that we're not the only game in town, right? And so in that sense, yes, so some of these companies definitely pay better. But I'll tell you what, I'd take our mission any day of the week, right? Exploring the frontiers for science, for new knowledge, for saving the planet. Like, this is good stuff that we're doing. And oftentimes what we see, and I think it's healthy, as Nagin said, that people will be with us for a while. They might go to Blue Origin or SpaceX or one of the other companies for a while, and they come back, and that's fine. They learn new things. They bring new ideas back. I think that's healthy, as long as we don't have too much of it. The right amount is good.
Yeah, that's definitely true. I mean, in terms of, I think we are all familiar with our colleagues or ourselves who have gotten the ping from Blue Origin or SpaceX or other companies. And again, it's great to trade talent. Sometimes that it's one thing within like the space ecosystem. Sometimes it can be a little tougher when it's Apple or Google and the dollar signs that they can dangle
That
are
was kind of where I was going.
Yeah.
I'm
It-
glad
it's a
you were
thing.
explicit and I was trying to be delicate.
Yeah, it's definitely a thing,
it's
right?
true.
Where they can, there are cases where the compensation packages that they can offer are really significantly different than when, you know, these companies that are taxpayer funded are of course going to have more, more reasonable salaries. But the challenge is to have an environment and to remind ourselves that JPL is still a place where you can build an entire career in deep space exploration or in Earth exploration. And there are other partners. When I wanted to work at JPL when I was 14, that's because it was one of the only places that you could do space exploration, robotic space exploration. Fortunately now there are lots of places that offer those pathways. But our mission, you know, when I depict the shirt tonight, right? The stars are calling and we must go. Sometimes why you do what you do is just as motivating as what you do. And that's what stays with you through the years. And we've seen people who leave JPL, and we were talking about this the other day, that you may leave JPL, but a lot of folks will come back. Because there's no place like it.
It's the people too. It's the teams too. The mission and the teams. You can
Some
probably
of
talk
us
about the people
never
you were,
leave. Yeah,
never leave ever.
I mean,
Yeah.
JPL is the only place in the world where I can do what I do, where I can walk from one day being in the lab, discovering a new mineral that may exist on Titan's surface, to the next day being like, oh, okay, has the rover, dropped out the last tube? Do we get to do proximity science with Pixel again? To being able to work with students and postdocs and be able to do these firsts that you can't really do anywhere else. So if my goal in life was to make money, I would have chosen a very different career. My goals are to build something and to work in teams that do things that last longer than just one person and leave a legacy. And I'm really, really happy to be a part of teams that do that.
More applause.
I'm taking you both with me wherever I go.
Oh my God. This is amazing, by the way. She's the director. She's right there. Yes. Sorry, I'm done. Mature.
I just hope we don't lose you to your mountain and the unicycle.
I promise I'll be careful.
Really. Or at least have like 911 on speed dial or whatever one has these days. Well, Nagin was talking about the idea that the rovers go to places that, people have never been. But isn't there also some work being done at JPL to check out I was going to say the dreadful mess our planet is becoming, but someone will say that's like biased or inaccurate. But could you talk a little bit about the Earth science missions?
Of course, I'm thrilled to. Yeah, so it is a big part of what we do. We're sort of known for our planetary science work, our work on our solar system. We also do astrophysics work. So one of the instruments on the James Webb Space Telescope, we had a big piece of that. We're working on future astrophysics missions. But the Earth science is really just so thrilling, and it's the place where we most directly connect to benefit to humanity, right? And we're very focused on that. So a mission we just launched in December called SWAT is going to, for the first time from space, accurately map the heights not only of the ocean, which we've been able to do for a while, but do that at higher precision than ever before and closer to the shore than ever before, which if you care about sea level rise is important, but also do it for freshwater lakes and rivers. Right now, if you have a stream gauge or a lake gauge, we probably know the heights of 1,000 lakes around the world. After SWAT gets its data, we will know the heights and be able to monitor them regularly of 1 million lakes around the world. Fresh water, where is it on this planet? How much is there? And what's happening to it? What a great question, right? So it's missions like that. We are currently from the International Space Station, and I understand we may have someone who has written software for this instrument right here, also a JPLer, measuring two different aspects of the changing climate, both looking at the mineral dust. So turns out the little fine dust in the atmosphere is an interesting swinger for climate change. It could cool the atmosphere, but it can also heat up the atmosphere. And so it's one of the biggest uncertainties. So understanding the mineral dust better is great. But it turns out it also can really detect very well methane super emitters. Methane, one of the most powerful greenhouse gases, way more powerful than carbon dioxide. Often, colorless, we can't tell where you can't see where it's happening except with this wonderful spectrometer we have on the space station. So we're finding these areas. Sometimes industrial folks don't even know they're a methane super emitter until we really tell them, and they're clamping down. And it's the one way we can have a near-term, a decadal scale impact on warming if we can reduce the amount of methane being emitted into the atmosphere through these methane super emitter, shutting them down. We can actually impact the rapidity of the climate warming. So anyway, I'll stop there. But
No, I'm fascinated. All those cows.
Yeah, and garbage piles is another big one. It's really interesting, and we're going to be doing more in that arena. As well, we have a mission coming up called Carbon Plume Mapper, which is actually a really interesting one where we're working with a private company called Planet up in the Bay Area to fly some missions to follow up on this methane super emitter idea at even smaller scales. And it's entirely funded by philanthropists, not a NASA dollar involved, not a taxpayer dollar involved. Yeah, it's a really interesting new partnership, right? So there's all kinds of new players.
I think we need the applause sign for the.
No, that's okay. Yeah, it's pretty cool. There's a lot going on. Yeah.
And aren't you also an investigator on a couple of Mars
Yeah, Nagin and I work together on
Curiosity.
Curiosity.
I'm
not
dragon
doing it myself.
boats and
In her
knitting
spare
and
time.
how do you have time to?
I
How do
don't.
you
I'm
balance
not
administrative duties and being an investigator?
Not very well, because I'm really not working on it very much right now. I'm kind of fully in director mode right now. But Curiosity, which was, so everybody probably knows Perseverance, our current big rover on Mars, it's like her big sister. I'm probably not supposed to refer to her with gendered pronouns. Sorry, but they're girls to me because they're smart and good looking. So
Cassini was definitely a she too.
Pardon, yeah. So Curiosity, which we landed in 2012 on my birthday, on August 5th, we landed Curiosity. And great, amazing, our first sort of mega rover on the surface of Mars. So yeah. We discovered with her the work I did there was working on water in the soil. So again, water and Mars rocks. That's my thing.
And Morgan is newly on the
Yeah,
Mars,
I am.
one of the rovers.
As of 1 year ago, pretty much last month, I am working on the Pixel instrument, which stands for Planetary Instrument for X-ray Lithochemistry. So litho is rocks, chemistry. I'm a chemist, woohoo. We're basically using X-rays to try to understand what these rocks are made of. And this is really important because this is the first time we're able to do this and map surfaces of rocks. So when it comes to geology and understanding how these rocks got to where they are and what they were exposed to, like, liquid water or things that might be important for life, it's important to see what minerals are next to each other. And Pixel is able to do that. It's one of many instruments on the Perseverance rover, and it's been such a joy and just so much fun to dive into this, incredible science. And it seems like every day we're driving somewhere new, we're doing something new. It's just awesome.
Yeah.
Every sol.
Every day.
Right, it's a sol.
Explain what a sol is for the audience.
So
And why you have to have a sol app on your watch. I have an ancient analog watch of the
but you're going
rover.
to tell them what your watch is.
Oh, yeah, I have an ancient analog watch given to me by Donna Shirley, who was the head of the rover team, and it's the little shoebox. Well, you especially can't see over radio, but it's the little shoebox rover, Sojourner traveling around in lieu of a second hand.
Just celebrated 25 years since Sojourner landed. That's amazing. Yeah.
So one of the things we do when we newly land a rover on Mars, or primarily rovers, but other assets as well, landers, is you want to take advantage of when you've landed, because you don't know how long your lander or your rover might last. You hope it will be years beyond the prime lifetime, but initially you have to take advantage of being on Mars. So we tried to live in sync and work in sync with Mars time. So a Martian day is called a sol, and it's approximately 40 minutes longer than an Earth day. And so in order for us to work the Martian night shift, because typically when the rovers will go to sleep is when we get the data of what they've accomplished that day, and we figure out what we would like them to do the next day, the next sol on Mars. So if we're going to come to work at 5:30 p.m. Mars local solar time every day on Earth, it means we have to come in 40 minutes later every day.
So you get to sleep in a little bit each day. That's awesome,
But
right?
it eventually catches up with you. It's like
brutal.
moving a time zone a
It's
day, which is why we only do it for 3 months.
Yeah.
And Mars time, and during that time, usually the entire team is physically together. And it's an incredible experience because you're getting to know the rover, you're getting to know where you are on Mars, you're a mess because you're moving a time zone every day, but it's just a blast with the shared experience of learning to work as a team. And I've done it 4 times, and I have to say this time was harder because we weren't together. It was during COVID, it was during the pandemic, and Mars time is very different when you are trying to rotate 40 minutes every day, but you're in your home and you don't have all of the camaraderie that is what gets you through Mars time. And maybe at some point we'll still get to gather as a team, but it is part of the Martian experience, right? The being a first generation Martian is to live on the Earth and work on Mars.
Yeah, you bet.
Yeah.
I'm just thinking about what the Clipper experience is going to be like, because a Europa day is 3 Earth days long. So this might be a little bit more challenging.
Yeah,
Well,
but
we're
you're
gonna-
not sure.
Yeah, I was going to say we're going to open it up soon, but speaking of the Europa Clipper versus, it takes a long time for a signal to get to Europa. Are the robots going to have more AI? Are they going to be more autonomous and be able to make decisions if it takes a long time for that signal?
That's a huge technology thrust for us at JPL is spacecraft autonomy, onboard computation. You'd be embarrassed, the computers that we fly on these missions that are space qualified, they're not very powerful, let's just say. And we need, especially if you want to do something like send big fancy radars, which generate tons of data out very far away, you want to be able to do onboard processing. You want to be able to do onboard autonomy. The rovers have quite a bit of autonomy, actually. They're pretty smart. They're, as we would say in Massachusetts, they're wicked smart. And they...
That's right. You were at Worcester Polytechnic.
I was at Worcester.
Insti-
Yeah, that's right. Yep. But we're working that each and every day to get better and better. And I think that's a very exciting part of our future.
And there is a step of the humans having to learn to cede autonomy to the robots,
Yes.
right? Not only do we have to initially, as part of our preparation, all teams, the scientists and the engineers will work together and practice in our operational readiness tests. How are we going to make decisions quickly enough to prepare for the next Martian day or whatever is the next day on the mission? But that's us learning to work together and humans each making decisions. It's been very interesting to watch this evolution of now, and in fact, on Perseverance, we are getting ready to roll out some of this autonomy where if the rover has resources at the end of its Martian day, then it can choose from a list of things that the humans have given it. But what it means is the next day when we come into the next Earth Day, when we come in to see what the rover's done, we are all grappling with the idea that the rover did something that we didn't tell it to do.
So
Yeah,
they're a little bit like
Humans have
helicopter
to-
parents,
Yes.
you know?
Exactly.
Like we
have to
must know what you're doing at all
to
times.
Let go. We have to cede autonomy. So the humans have to be trained as well.
And speaking of that, Ingenuity, I think, is a great example of being able to
Helicopter.
fly autonomously. And certainly
Yep.
the Dragonfly mission, when that gets to Titan, the one-way light time between Earth and Saturn's moon Titan ranges from like an hour to, I think, an hour and a half. So it's going to have to do these fully autonomous flights and handle
No
that all by
joysticking.
itself. Exactly. No
Yep.
joysticking.
Well, we're going to open it up to questions soon, but I did have just a kind of an an annoying thought based on the, based on the podcast. In the early days of JPL, the pioneers were considered wacky, because they were pursuing rocket engineering before rocket engineering was even a field. And hearing
pretty
Nagin,
dangerous, yeah.
Yeah, hearing Nagin say that wrecking your circadian rhythms for 3 months was a blast. I just want to throw out the question, do you have to be, a little think out of the box, wacky to do the kind of work you do at JPL in the best sense?
So I would just say, I did a series. So I've been here about 8 months now, and about 3 or 4 months in, I did this thing called Engage JPL, where I had all these sessions where like 200 people at a time, we got together, we'd spend 2 hours talking about all kinds of stuff and asking people like, what's one more thing I need to know? And I'll just never forget what somebody wrote on one of these Starburst things from their table after their whole table discussion, what's one thing I should know? And their thing was, keep JPL weird. And I loved that, right? And so like we are this awesome combination of intense creativity and super nerdiness. And there is something a little weird about that, and I dig it.
Oh, a big applause. I think big applause. And maybe at that, unless you share, that's like why you're good at this president thing, because you just brought it all together. Maybe we can open the questions up to the audience. I think there's a mic down in front here. Becca, I'll let you.
And I designed, actually, none of them were at JPL when I was there 30 years ago. 30 years ago,
Pioneer
this
right
month,
here, pioneer.
I designed the Flight System Test Bed and the Project Design Center, and this young lady used a wonderful Daniel Golden, cheaper.
Better, faster,
Do
cheaper.
you know
yes.
where that came
Yes.
from? So that was the only artwork that I put into the Flight System Test Bed, so that's for you. And then MG and I met at the Getty, and she then did an article in Dwell magazine about me, and she said, interior design, it is rocket science. And so I'm not an engineer, but I spent a year there, and it is exactly what you said. It's weird, and it's supposed to be, and when I've met many people at other facilities, they all go, is it really true? Are you guys really crazy? And the answer is yes.
Just the right amount.
It's
just the right amount of crazy.
So
you
I want to say
gotta
this
be a
has
little
been
bit.
wonderful. But I have two things to say. I'm a solar system ambassador now.
Oh, wonderful.
Yay,
Thank you.
thank you.
And it's all about outreach.
Education
So to
and
all of
outreach,
you, whether you have a school or a group or whatever, you can apply very easily and ask for a speaker. And so I'm on the NASA Speakers Bureau also.
Wonderful.
I am. This is what it's about. And does anybody in this room besides them know how many flights Ingenuity, the helicopter on Mars, has had? Well, I would hope. Wait, Laurie, I would hope you know. Does anybody in the audience? So think about this. All the things that go wrong, we have a helicopter on Mars. That's number one. It's flown 39 times.
Okay, applause.
And one thing that if I could follow up on that is, as Roxanne mentioned that she was an interior designer, and that reminds me to say that there are so many different types of roles at JPL. And please, spread the word. We tend to talk about scientists and engineers, and yet we have so many different kinds of roles, from graphic designers to writers to news
Business
people to
people,
business
yeah,
people
finance.
to it
Lawyers.
takes a
You
village.
can be a
is very
space
true.
lawyer. It's a thing.
You have a space lawyer.
Actually, that's probably a really interesting field, but Becca, there you go.
Hi, I'm Jim. I was one of the kids who watched Neil Armstrong walk on the moon when I was
Nice.
5 years old. And so watching Artemis take off 50-some years later, that was just everything I could hope it would be, and I hope that inspires a lot of folks. You were talking about the Pixel instrument, and it's utilizing X-rays to do Well, I don't understand how you're able to do chemistry with the X-rays. I'm an X-ray tech by trade. I look inside people. Just that's how I make a living. But I'm kind of curious how the X-ray interacts with the rocks on Mars to create this information for you. It's fascinating for me. I'd kind of like to know more.
Sure. So it's similar to how we do X-rays for our bones, and X-rays can penetrate our soft tissues, but they can't penetrate our bones, and that's because the elements inside of your bones have a higher mass. Their nucleus is larger, and so the X-rays basically diffract or they bounce off, and we can do that. Apply that similar principle because the X-rays will interact with elements of different sizes differently. And so what we do is we have an X-ray source that fires down into the rock, and it gets really close, like 3 human hairs close to the rock. So we actually had to do a lot of development to be able to position the instrument that close without actually touching or scraping or bumping the surface. And then the X-rays will bounce or interact with the whatever mineral is there. And then we have 2 separate detectors that we can use to look at that signal that comes back. And we've actually found that there are a couple of different ways that Pixel can operate. It can look at how that energy is absorbed and emitted or how that X-ray is diffracted. And so it's really cool that we can be able to tell not only what elements are there, but we can get at some of the bonds between the atoms, the structure, which is really important. And so then Pixel starts to scan across the rock, and then it generates a map of that composition. And the other really cool thing is that it's not just Pixel. We have another instrument on the arm called Sherlock, which does UV fluorescence in Raman. And so that can get us at better understanding also minerals, but if there are organic molecules there too. And so the power really is having both of these synergistic instruments together to have overlapping maps of all of the cool stuff that's happening with each of these rocks every single time we drive up to, well, almost every single time. Yeah. And so it's really
cool.
Fascinating.
Different wavelengths of light, right? So X-rays is one, UV is another. Wavelengths of light our eyes can't see interact with these rocks and get absorbed in different ways that are distinctive of depending on which different chemicals and different minerals are there. So we do a ton of lab work to support this to understand what does that squiggle mean? Oh, it means it's a pyroxene or whatever it is, right?
And now you can see what my day is like as an engineer.
Yes, we're just nerding out, and she's like, whatever, what command do you want to send?
All of the time.
Actually, that was going to be one of my questions that I passed over about is there a tension between the engineers and the scientists?
No,
I'm married
absolutely
one,
not.
so does that count?
Just everybody wants to do everything, and there's not enough time. So there's not a tension, although that's different than when we're landing. And initially, when we're landing, as we were getting better at landing on Mars, it started with the engineers being, I remember the scientists wanted to land in like Valles Marineris, and we're like, that's like the Grand Canyon of Mars. And the engineers were like, no, flat, boring, no rocks. And so we had to get better at it. So now we finally improved our landing ability to the point where for Perseverance was one of the first times that the scientists were able to choose of their top 10, there was no engineering recommendation of which ones. We could do all of them, and they're like, can we go here? And we're like, yes.
Yeah.
And they were like, you're kidding. And then they had a field day, right? So we have gotten better so that we can.
That just
Our goal
means
as
they
engineers,
revise their list.
our goal as engineers is to have the capability to be able to provide whatever, allow the scientists to go where they need to go to accomplish our science objectives.
And it's huge.
So we work together.
Yeah, there's
I have
a question.
A question about sort of money, history, and administration. When I was a grad student 40 years ago, you went to JPL, you came up with an idea, and you hoped within 20 years somebody would give you the money to do it. It's my impression things happen much faster now, and there's a lot more going on. Is that just because technology has advanced so much, or is there a difference in procurement and government funding?
I think it's a little bit of all of the above, but you're right that it used to be, and others can jump in here too, that we might be working on 1 or 2 big missions at a time. And then a bunch of technology and other cool stuff too. Now we are working on 40 missions. But ranging from, Europa Clipper and Mars Sample Return, gigantic multi-billion-dollar things, right? That we're like Europa Clipper is currently in our clean room being built to launch next year. Very exciting. Mission to Jupiter's moons. We can talk about that later. Morgan can give you all of it. And we just launched a little tiny mission to the moon called Lunar Flashlight that is a kind of tech demo. And so one of the cool things about the space ecosystem evolving is a lot more small satellite providers are out there. We may not be building those missions ourselves in-house, but we're involved in missions of all sizes and scales now. And so we can launch things faster, we can build things faster, and that is really exciting. It also means we can feel a little schizophrenic sometimes, like we've got a lot going on and trying to make sure that everything has the staff it needs and the attention it needs. So that's kind of the challenge that we face today. But boy, that's a great problem to have because we're just exploring everywhere.
Just keep it weird. There's a question. Yeah.
Hi.
I think you should use the mic for
Is
the
it-
podcast.
is it-
so
oh,
they
it's
can
working
hear
now.
you.
Okay.
Yeah.
Okay.
Yeah.
Thank you so much for being here. It's been amazing to see you guys. And we've been talking about all this pure science, and I completely appreciate that. But I want to know all of your opinions on what you would think the most profitable part of space would be if it's like, you know, commercial space, taking people to space, or meteorite harvesting. I want to hear your true opinion because I know you've thought about this. So what do you think the most profitable part of space would be in the next 20 years or so?
Engineer should start.
First of all, I love your jacket. Very nice, very nice.
Describe it for the podcast.
So she's wearing a red jacket with all sorts of awesome mission patches on it. So of course that caught the eye. So from my perspective, one of the areas that I've heard the most movement in is in the area, as you said, of resource mining, right? Looking at the asteroid belt, looking at other worlds for what possibilities are there to add to our resources. Not in a, we've used up the Earth, let's go trash someplace else way, right? But in the challenge here is right now the UN Outer Space Committee, you know, the treaties that exist are ones that say that space is for everyone and that no country can go and like plant a flag. But we as everyone, you know, as we think about it, if a commercial company is going to go and expend their money to try to mine resources, there has to be profit in it for them. So I know I have colleagues that are involved in this, in the space law, as we were talking about it. One of the challenges, how do you encourage the innovation and the what the commercial companies might bring, while also kind of not sending us down a darker path of I can own this property. So there's exploitation versus innovation, and so I think that's an area where there certainly are possibilities, but I am encouraged and I'm reassured that there is an organization within the UN that is addressing this, because just because we can do something doesn't mean we should. And so I am glad that there are organizations thinking about the ethics of this, and that's a plug for the space lawyers that we also
I was going to say, it
have.
sounds like space lawyer is a burgeoning field, but a
Super cool.
science response or
Honestly, I hadn't really thought about it that much. Like,
I think
this
in the
was
near term, it's Starlink, it's space-based internet, it's going to be more in the near Earth space, and you just see and this is a little scary from the orbital debris perspective. Like, literally, our new wonderful Earth science mission, we had to do a little divert maneuver a couple of days ago because of space debris, right? So it's getting crowded up there, and lots of companies are talking about launching literally thousands and thousands and thousands of satellites so that we can have wonderful, cheap satellite internet, which is great. But so there's going to be that. To me, that's going to be the next big frontier.
I think we have time for one more question.
Oh, sure. Also cool shirt. Yes. Uh-oh. It doesn't seem to be on.
Hello?
Oh,
Okay.
there you go.
I saw online that you had an Artemis Gateway. It's like a
gateway, mhm.
gateway, so it's going to be like a Hubble type thing?
It's
or,
like the
International Space-
ISS for the
ISS
moon,
For the moon. So
International Space Station, sorry.
are we going to be able to have more gateways between the moon and Mars, and maybe have some like CubeSat satellites between, so we can do faster relays? So when we get to Enceladus and Titan, so we can have more relays and then have more these gateways and more connection, maybe to we get to the end of our solar system, like where
Yeah,
Voyager
awesome
is.
question.
Thank you.
You wanna check? Yeah.
Well, he did mention Enceladus, which is a really fascinating moon of Saturn that is spewing free sample of its ocean into space from these giant cracks, and it's a
Yes.
wonderful place. And we have done some studies to look at how to send a lot of data back, because as the further away you get, you can sort of picture the data stream as a pipe that gets more and more constricted. And so it would be amazing if we had some sort of relays that were further out that could act as sort of data storage and then slowly trickle that back to Earth, because I would love to have the images, the videos that we have from Mars at some of these places like Titan and Enceladus. And so there are a lot of studies that are ongoing, and I think that's really important work to continue to support.
Yeah, I think that you've really pulled on a great point, which is, we like to say at JPL, we do one of a kind, first of a kind, right? Cassini to Saturn, and now we're getting ready for Europa Clipper and talking about missions to Enceladus and, with
Helicopters.
and helicopters on Mars. But the truth is that to do this sustainably, to really do it for humanity over the long haul, like we go first, right? But then you got to have something that follows that's more infrastructure oriented, that where you really are thinking about a more sustainable exploration strategy. And so NASA's spending a lot of time thinking about that right now on the human spaceflight side. I think we need to do more thinking about it on the robotic spaceflight side. We only go to the outer solar system once every other generation. It's too long. There's too many fascinating worlds out there. We've got to figure out, how do we go faster? How do we go more frequently so that every time we go, it doesn't have to be a Christmas tree of stuff, because you only get to go once. So you got to put everything you can think of. There's a bunch of things like that. We need innovation and creativity around some of those, that basic infrastructure that's going to open the outer solar system. That's a great question. Thank you.
That was awesome.
I think I'm getting that sign. I'm not taking it personally, because this has been an awesome panel. And I think maybe you'll have the opportunity to chat with a few of them afterwards or stargaze, with the podcast, I usually say, because of the JPL history, come for the science, stay for the squalor. In this case, it's come for the science, stay for the stars.
Stay for the stars. I love that. Thank you.